All right, so in terms of what we're going to do this week, we're going to discuss a little bit more in detail some specific viruses. We're also going to talk about how those particular viruses are transmitted. And in terms of that, I've got an example of a virus for each of these methods of transmission. All right. In terms of how viruses are transmitted, first one is probably the most common and the one you're probably most familiar with, and that's going to be respiratory. So in terms of that, those viral particles can be released into the air, into the atmosphere. You breathe them in, and then those viruses attach to your epithelial cells and infect those cells. All right. The example I have for a respiratory virus is going to be the flu, all right, because that's one you can probably relate to. Likely everyone has had the flu at some point. If you've been lucky enough not to have the flu, you at least know someone who has suffered from it, all right? But there are many more viruses that are transmitted via respiratory method. The measles virus is a great example of another virus that's transmitted via respiratory. One of the things about the measles virus that's kind of unique is measles will actually hang out in the air for several hours. So if, for example, somebody has measles and they step into the elevator, they breathe in and out, they release those viral particles into the elevator, they get off the elevator to go to their doctor's appointment. Hour later, you walk into that elevator, those viral particles are still there and present, all right? You can breathe those in, and in terms of that, that's how you are then exposed to the measles virus, all right? And in terms of that, that's why vaccination is so important for things like measles, as well as things like chickenpox and mumps, all right? One of the things that we've kind of become, I think, socially oblivious to is that people can die from these viral infections. We don't anymore because of vaccinations. So it kind of seems like having the measles, having the mumps, having chickenpox isn't quite so lethal as it used to be. And the reason why is because we have vaccinations. All right, I'll have another video later on this semester where we'll talk a little bit more about vaccinations. All right. But in terms of respiratory, that's going to be the main route of transmission for viruses, all right? Fecal-oral, this is the one that's got the ooky factor associated with it, all right? Because when we're talking about fecal, we're talking about solid waste. We're talking about essentially poop, all right? That fecal material winds up back in your mouth, and that then allows the virus to propagate within your body. The polio virus is the example I'm going to have for that one. There are many other viruses that will be transmitted by fecal-oral route. Some rotaviruses are transmitted this way. So in terms of that, in daycares, a lot of times rotaviruses will kind of take hold because you've got workers that are changing diapers. Maybe they don't wash their hands between kids, or maybe the kid goes and sticks their hand down in the diaper, puts their hand in their mouth. That can expose them to viruses that way. The example I'm going to use, though, is going to be polio. All right. You can also have transmission of viruses via blood products, and there are a lot of viruses that fall under this. The one I'm going to use is going to be Ebola, because that's really how it's transmitted person to person. Ebola, though, kind of exists out in the world somewhere else. It doesn't propagate necessarily within the human population, but blood or urine products are ways that that virus can be transmitted to other people. All right. Sexual transmission. In terms of that one also kind of self-explanatory. HIV is going to be a virus that's transmitted sexually. HIV can also be transmitted via blood product. So when I'm talking about these, some of these viruses do have multiple modes of transmission. So it's not just necessarily one. But HIV is one that's associated with sexual transmission. The other one that I will talk about that I think is a bit more relevant because it's a little more prevalent in the population, and I don't want to downplay HIV because that one is also a very important virus for you to understand a bit about as future healthcare professionals. All right. HPV is one you may or may not have heard about before. That's the human papillomavirus. Human papillomaviruses can give rise to sexually transmitted diseases like genital warts. It also can cause cancer. Okay, so I'll talk a little bit more about HPV. And then you have vector-based transmission. Here we are talking about transmission via an animal or an insect. All right, and the one I'm going to focus on, since this has been in the news lately, that insect transmission is how the Zika virus is transmitted. All right, so in terms of that, the Zika virus, I've also got a bit on the dengue virus because Zika and dengue are kind of related as far as the virus structure goes and how they're transmitted. So I've got both of those in there. All right. But what we'll start with as far as viruses right now, we'll talk about influenza virus. Specifically influenza A. There are some other subtypes of the flu that are kind of less virulent. Influenza A is the one that tends to get you really sick. Can land you in the hospital if you end up becoming dehydrated. Okay? And in terms of, oh goodness, there goes my spelling. The influenza virus, it's what's known as a myxovirus. And that's just the classification of the virus. All right. It is an enveloped virus. So it is released from the cell by budding. All right. And in terms of influenza, the reason why you need to have a flu vaccination every year is that influenza virus can undergo change. All right? And there are two types of change that we can have. We can have what's known as antigenic shift. All right? Antigenic shift involves some genetic reassortment. All right? So if we have our human flu virus here, and let's say that we've got an avian virus here. And in terms of that, avian's one that antigenic shift can occur with. Swine or pig is another one where human flu viruses can kind of combine. And essentially what you end up having happen is you create something new. So you've got portions of that human, you've got portions of the avian, and in terms of that, where that recombination usually occurs is in another host. And the host example we'll use here is going to be pig, okay? Because that's one of the common vectors for that. When you get that human flu virus combining with the avian flu virus to become something new in terms of occurring within that pig, you now have a new virus that can infect humans. Okay? So when we're talking about antigenic shift, you've got to have genetic reassortment. You've got two different flu viruses that come together to create something new, okay? The other way that the flu virus can undergo change and why you have to get the flu virus every year is you can have what's known as antigenic drift. All right? That antigenic drift involves mutation. Okay? The change doesn't typically end up being quite as big with antigenic drift, but you get the same thing that happens. If you get that mutation that happens, you now end up with something that's new, okay? But the new that's associated with this is now due to mutation, okay? So in terms of that, with the flu virus, you've got change that happens. Those ways of that change happening are antigenic shift and antigenic drift, all right? So those are two terms that I want you to be familiar with, and that's why each year you need to have a new flu vaccine, because what the CDC does is they take their best guess as to which flu strain will be active each year, okay? Sometimes they get it right, sometimes they don't. That's why you can get your flu vaccination and still end up with the flu. Because what likely happened, the strain of flu that you contracted wasn't what you were vaccinated against, okay? So in terms of that, the reason you need to get your flu vaccine every year is because the flu virus does change, and it changes relatively frequently, okay? I hope that makes sense. If you have any questions, please let me know.